So now I want to talk about radioactivity. Um, Nuclear reactions are not the same as chemical reactions. First of all, in chemical reactions, we're talking about exchanges of electrons, so we're sharing electrons. We are dealing with the nucleus in nuclear reactions, and so really they're extremely different. As we already mentioned, different isotopes can undergo the same chemical reactions and it'll happen the same way. So with nuclear reactions, what we're really looking at is what's going on in the nucleus. How is the nucleus breaking up, or how are we adding something to the nucleus? So the nuclei of unstable isotopes are called radioisotopes, and the whole point of a nuclear reaction is that they become more stable by changing in some way. So an unstable nucleus is going to release energy by giving off radiation, and that's what we call radioactive decay. There's three types of radiation. There's alpha radiation, beta, and gamma radiation. Each of them is a little bit different. As you can already see here, the alpha particles are going to be positively charged because they are going to curve toward the negative end there. Beta particles are going to be negatively charged because they're pulling toward the positive end there. And then gamma rays, no charge. So first type is alpha radiation. An alpha particle is a helium nuclei, and it just doesn't have any electrons with it. So they are emitted. It has 2 protons, 2 neutrons, double positive because you have 2 protons there with no electrons. This happens when a nucleus is too heavy to be stable. So if it's too heavy, it will emit an alpha particle, which is the biggest type, largest, and so that way it'll take the size down. Now, notice that in a nuclear reaction equation, all of the numbers add up to equal one another. So you have 92 down here. 90 plus 2 gives you 92. So there's that on the bottom, but then there's also the same thing with the top. There's 238 on top. 234 plus 4 is going to give you your 238. So we're conserving mass here, and all you have to do to kind of figure out what the products are, if you know that uranium-238 undergoes alpha emission, you just do 92 minus 2 to get 90, 238 minus 4 to get 234. Beta radiation is when a neutron breaks apart and forms a proton and an electron. That electron is called a beta particle. So this is what a chemical equation for that would look like, or a nuclear equation rather. Once again, the numbers add up to equal one another. 14 and 0 on the top would give you 14 on the top. 7 plus negative 1 is 6. So if you know that this undergoes beta emission, you can just do 6 minus a negative 1 will give you 7. 14 minus 0 is 14. Gamma radiation is just extra energy that's given off, so it doesn't have any numbers associated with it. It doesn't have mass or whatnot, at least that we're concerned about. And so it's just radiation that will sort of be like a side product when something else is emitted. And it's very high energy, very high energy. So here are penetrating powers. An alpha particle can be blocked by a piece of paper. As we've already talked about with that article you read, it can't penetrate the skin. However, beta particles and gamma rays can, and to stop a beta particle, you'd have to have some form of wood at least, and then some gamma rays can even make it through lead or concrete, so they are very able to penetrate. These are symbols. So an alpha particle sometimes will have the alpha symbol, sometimes it'll be written with just the helium symbol. This is those are the symbols for a beta particle, and you just have some penetrating powers, things that can shield it, all that sort of stuff. Alright, I think that's a good place to stop for this one.